Now we'll explain the properties of solids, liquids, and gases from molecular point of view. Now first we come to the arrangement of the molecules. In solids we see that these molecules are so close to each other. Okay, in liquids they are a little further apart, and in gases they are far away. There's a huge distance between them. So that was the first point. Here the particles are closely packed, here closely packed. Here the particles are loosely packed, are less closely packed, okay, are less close, and here they are free to move, so they are less loosely packed. Now we go to the force of attraction. Now in solids, since the particles are close, the force of attraction between them is large. There's a huge force of attraction between the particles. And that's the reason why the particles are unable to move around. They're close to each other. Okay, and that's another reason why solids have a fixed shape. So we see the force of attraction in solids is large, and hence the particles are unable to move, and because they're unable to move, the solids have a fixed shape. Particles unable to move. Unable to move from their position. And hence they also here have a fixed volume. Now let's get on to liquids. Now in liquids there is a force of attraction, but it's very less. The force of attraction between the particles is less, since the particles are very loosely packed. So here we have force of attraction is less. And since the force of attraction is less, the particles are able to move. Not much though, but they're able to move around. Move within the liquid. Okay, so force of attraction is less. Particles are able to move within the liquid. Now when we come to gases, the force of attraction is negligible. You can say there is no force of attraction. The particles have so much of energy that they are free to move wherever they want. So here we say force of attraction negligible, and particles free to move. No fixed volume, no fixed shape. We go to the next point, and that is the intermolecular spaces. In solids, the intermolecular spaces are very less intermolecular spaces. In liquids, the intermolecular spaces is more. But in gases, the intermolecular spaces is huge. It's large intermolecular spaces. Okay. So I'll repeat again. In gases, we saw that the intermolecular spaces were less. Here, less intermolecular spaces. And because the intermolecular spaces were less, the solids cannot be compressed. They cannot be compressed. There's hardly any more space to compress them. In liquids, the intermolecular spaces are a little more. There are more spaces between. Since the force of attraction is less, the spaces are a little more. So greater spaces, and because the spaces are greater, liquids could be compressed to a very small extent, okay, very small extent. But when we come to gases, the intermolecular space is so large. We have large intermolecular space, and because it has got large intermolecular space, gases can be compressed very easily. You can compress gas, you can reduce the volume of the gas very easily.